Today our task is going to be to graph all 6 trig functions. It's going to be important to note here that when we graph trig functions, we are always going to work in radians. The reason is because the scaling with radians works out better than with degrees. Also, radians are going to be more relevant for us as we continue to move forward. So the function I'm going to work with is f of theta, which equals the cosine of theta. But instead of theta, we'll likely just use x, and we'll likely just say f of x, which equals the cosine of x. I'm going to start with the table of values. I'm going to find my x values and my cosine of x values, which is my y values. I'm going to start at the big ones. So I'm going to start at 0 radians, and I'm going to finish at 2 pi radians. At 0 radians, my cosine value is a positive 1. At 2 pi radians, my cosine value is a positive 1. So I'm going to come down, I'm going to plot that point of 0, 1, and 2 pi, 1. So my y-axis is going to go up to a value of 1 and down to a y value of negative 1. I'm going to split as close to in between as I can. I'll call this pi. At pi, my cosine value will be a negative 1. I'm going to plot that point, and that would be the point pi, negative 1. I'm going to split again. In between 0 and pi would be pi over 2. And I know based on the unit circle, I know based on how I evaluate the cosine, that the cosine at pi over 2 is 0. So if I plot that point, this is at pi over 2. I can also split in half between pi and 2 pi will be 3 pi over 2, or 1.5 pi. That would be my negative y-axis on the unit circle. The x value on the negative y-axis would be 0. So I can plot that point of 3 pi over 2, which is a 0 value. In between, again, I'm going to keep splitting in half. I have pi over 4. The x value there is root 2 over 2. I have 3 pi over 4. The x value there is negative root 2 over 2. 5 pi over 4, which is also negative root 2 over 2. And 7 pi over 4, which is positive root 2 over 2. It's important to note that root 2 over 2 will be approximately 0.707. So between 0 and 1, a little bit closer to 1. So if I'm plotting those points, I'm going to be here, below the x-axis, below the x-axis, and above the x-axis. I could also count by pi over 6's. So at pi over 6, the x value will be root 3 over 2. At pi over 3, the x value would be 1/2. And I could keep going with that. 2 pi over 3 would be negative 1/2. Go ahead and fill in the rest of these. Again, something to keep in mind, the square root of 3 over 2 will be approximately 0.866, and 1/2 is obviously 0.5. So if I plot these points here, root 3 over 2, 1/2, negative 1/2, negative root 3 over 2. And what I'm going to see here is a smooth wave. I'm not sure quite how well I can draw this, but we're going to get a wave that's going to have a y-intercept of positive 1, and it's going to intersect the x-axis at pi over 2 and 3 pi over 2. This is what we're going to call one full period. We're going to be able to copy and paste this one section onto either end of this graph to get the entire image of the cosine function. What I've shown here is a domain from 0 to 2 pi, or 0 to 6.28, but it is important to note that the domain for this cosine function will be all real numbers. The range for this cosine function will be including negative 1 up to positive 1. We're going to take a look at this in a couple other windows. First, we're going to go to our calculator. We're going to graph y equals the cosine of x. It's important to note we need to make sure we are in radian mode, which we currently are. So we're going to graph cosine of x. Zoom. I usually go with Zoom Standard, which is option 6. Zoom Standard goes from -10 to 10, -10 to 10 with a x scale of 1, as I can see here in my window. But I'm going to do a different zoom this time. I'm going to do Zoom Trig, option 7. Option 7 here sets a different window that is more relevant to graphing trig functions. We can see on the right side of the y-axis is the exact same image that I just showed, except we have another period over here on the negative. The window for Zoom Trig goes from almost -2 pi to +2 pi. I'm not sure why that's not exactly -2 pi and +2 pi. It has an x scale of 1.57, which is pi over 2, and it goes from -4 to +4. So here we can see we intersect the x-axis at pi over 2, 3 pi over 2, pretty close to one full period here on the right side of 2 pi. Another tool we can use is Desmos. So here I've graphed cosine of theta. This actually accepts theta. We could have typed in x just as well, but x and theta are the horizontal axis. Right now my window is from -10 to 10 with a scale or step of 1, -10 to 10 with a step or scale of 1. I'm going to adjust these to be -2 pi to 2 pi. I'm going to change my step. Instead of 1, I'm going to change this to be pi divided by 2. In the y direction, I'm going to change this from -2 up to 2 and keep my step of 1. I do have the option to show my graph in degrees. I don't want to do that. As we can see, the image completely changes. We can discuss why, but we're going to graph this in radians. So if I check out this image, I actually have two full periods, from -2 pi to 0, and from 0 to 2 pi is that one single period intersecting the x-axis at pi over 2 and 3 pi over 2 intersecting the y-axis at 1. The domain will be all real numbers. There are actually infinite x-intercepts if we continue this all the way out to the right and all the way out to the left. Some values that we can see. If I find the x value of pi over 6, I get 0.866. At pi over 4, I get 0.707, which is the square root of 2. And at pi over 3, I get 1/2. I could continue with this. At pi over 2, I get 0, and I could follow that trend that came from the data points that I had used to generate my own cosine curve. I'm going to ask you to either use your calculator or Desmos or plotting points to graph one period of the following functions. I'd like you to start, if you have not already, with the sine of theta or the sine of x. And immediately below the sine of theta, I would like you to graph the cosecant of theta. Keep in mind the relationship between sine and cosecant. I would also like you to graph the cosine of theta, which we've already developed, and immediately below that, I would like you to graph the secant of theta. Again, keep in mind their relationships. Two other functions that we want to finish with would be the tangent of theta and the cotangent of theta. For each of these functions, I would like you to list the domain as well as the range. I would like you to think about a period length. What is one section that we could use to copy over and over and over to get the complete graph? Other things that might start to pop up are going to be vertical asymptotes. We didn't see that with the cosine function, but we will see that with some of the other trig functions. So for right now, get down those 6 functions, whether it's using your calculator, Desmos, or plotting points, and think about those key features. The next step will be to graph a function like 2 times the sine of x plus 4. We would need transformations there. Think about what the 2 might do, think about what the 4 might do. Good luck.